Of course, now that we've got that feed set up, we'll want to automatically send data from our thing to it. Let's show how to do that with both a Raspberry Pi and Python, as well as a Feather ESP and C++ Arduino. Let's start with a Raspberry Pi with Python. We've already set up the Pi's operating system and Wi-Fi. We'll wire up the sensor over I2C and then run this Python script. For our sensor, we'll use the ADT7410 from Analog Devices, which is a high-precision temperature sensor with I2C interface. This is the code we have running on our Raspberry Pi, written in Python. As you can tell, it's pretty simple. We're going to be using the Adafruit IO REST client. We set up our IO key and the username. That's how we authenticate. Then we connect to the service, set up our feed, add a little bit of CircuitPython library code to talk to that ADT7410 sensor. And then finally, in our while loop, we simply read the temperature and then send it to Adafruit IO, wait a few seconds, and then repeat. As you can tell, it's pretty simple and works quite well. Once you've got your hardware set up, go to your Adafruit IO account and visit the monitor page. This is where you can see live data streaming in as it's written to Adafruit IO. You can see the timestamp, the feed, as well as the data being written. This is great for debugging your project because you can see data coming in live. And if there's any errors or typos, they may appear in the live error section. Likewise, here's an example using the ESP8266 Feather with an OLED on top and an Analog Devices ADT7410 wired up on a breadboard. With the ESP Feather, we're stuck with a microcontroller rather than a full computer, so we don't use Python. Instead, we'll stick to Arduino C++. The trade-off is we have much lower power usage, so we can run it off a battery, and faster boot. But we also have to be more careful with memory and link management. Here's the Arduino code for the Feather. Like the Python code, it's pretty simple. We still need our Adafruit IO username and key. This time, because we don't have an operating system to manage the internet, we'll also need to put in the SSID and password. After that, we initialize the sensor and also the Adafruit IO feed object. In the setup, we connect to the sensor, connect to Adafruit IO, and then wait to make sure that we've connected. Once we're connected in the loop, we have an IO run procedure that takes care of background tasks, reads the temperature, and then saves it to Adafruit IO. Afterwards, we just wait and then run the loop again. And as we can see on the OLED, it's also printing out the temperature and sending data successfully. Over at Adafruit IO, go back to the monitor and you'll be able to see the Huzzah temperature data come in, just like you did with the Raspberry Pi. Once you've got your Huzzah or Raspberry Pi sending temperature data to Adafruit IO, you can visit the feed page. Here you can see every single value with the timestamp of when it was received, as well as view a plot of historical data of your entire feed.